Good evening students, this is Dr. Shubhi and today in this lecture we will be discussing what is correlation. You all have seen that statistics is a very good tool which is rather a collection of tools, and we can apply all those tools to analyze our data that we collected during the primary data collection. So now we will see a technique correlation where there is an indicator which is called as correlation coefficient, and it is used to measure that how strong is the relationship between two variables. We call it Pearson's correlation, and it is used to understand the strength of the bond of relationship between two variables. For example, there are two variables like rains and drop in the purchase of grains. So how far these two variables are connected, that in the when it is rainy, do people purchase grains or not? So we will see that how we can measure this relationship in terms of numbers and understand that what is the strength of the relationship. Are they weakly connected or very strongly connected, or there is no relation between the two variables? So all these aspects we will see very easily with the help of correlation coefficients. Now you all can see -1 to +1. -1 to +1 is the range in between which the correlation coefficient value varies. Now to determine how strong the relationship is between the two variables, first of all you need to find out the coefficient value, and this value can vary between -1 to +1. Now have a look on these graphs and you will understand the types of correlation coefficients. Now, in the first case, the A case, the value of R is greater than 0. R is denoted for correlation coefficient and it is greater than 0, which means there is a positive relationship between the two variables. Or I can say in other words that if the one variable increases, the other variable also increases. So there are two variables on the x and the y axis, and both the variables are increasing and they have a positive relationship, that there is a direct impact of one variable on the second variable. Now we will see one more case where R is less than 0. Here you can see that the increase in one variable decreases the value in another variable, or we can say that there is a negative relationship between the two variables. It's a negative relationship wherein if increase in one variable increases, decrease in another variable takes place. You can see this is a scatter diagram and you can see the dots over here. You can take an example of this, that increase in the home remedies. Increase in the home remedies of stuff used during any disease can drop the purchase of any medicine. So increase in home remedies, the usage of home remedies is decreasing the usage of medicine. That is how this relationship is. So here you will find that the relationship is inversely proportional. The third one is the diagram where the value of R is 0. R is 0 means that there is no relationship between two variables, which means the value of one variable does not affect the value of another variable. For example, you can take an example like increase in temperature decreases the usage of we can say decreases the usage of woolens. So this is what kind of relationship? Increase in temperature, which is warmth, increase in that decreases the purchase of woolens. This is a negative relationship. That is, increase in temperature is decreasing the sale of woolens. So it is a negative relationship. Now another is increase in temperature decreases the usage of wearing cosmetic. So there can be some relationship, but there is actually cosmetic has nothing to do with temperature. People will do it whenever they feel like. They whether it is cold or uh, warm, they will always apply cosmetic because they know they will go in ACs and sit, and somehow they will manage, and they have to look beautiful. So that is a according to me, there is no relationship between temperature and the usage of cosmetic. No doubt few people might exceptional cases are always there who will try to say that in during the temperatures we don't apply cosmetic, but they are outliers. They are the exceptional cases. In a totality, if we see general public, if we take samples of general public, we will come to know that there is no relationship between the increase or decrease in the temperature and the usage of cosmetic. We can take one more such example where there is no relationship between the two variables. For example, uh, increase in the temperature causes drop in the sale of kites. So these are two variables which are not dependent on each other. They are not affecting each other. If people are interested, they will purchase kites, and if there is temperature, then also people will no matter what, the people will purchase kites. So there is no relationship of between the heat and the kites, the sale of kites. People are fond of, they will do it. So there are n number of such examples with the help of which we can understand that what type of relationship is there. Now your one assignment is that on the basis of these four graphs, you have to write down one example of two variables for a positive correlation coefficient, negative, and no relationship at all. So in that case, you have to think and you have to check into the environment how the variables are there in an organization and how they are affecting. For example, if we take an example of an organization, and if I'm let's say selling the product like cold drinks. So I can have two variables: increase in the sale of cold drinks with the increase in temperature. So there is a positive relationship. The increase of cold drinks is always there with the increase in the temperature. But do we have the same same relationship or the same kind of graph going for cold drinks and decrease in temperature? And do people like to drink cold drinks in winters? So that's a question mark. So there we try to understand the scenario and we try to find out what is what. And is there any relationship between temperature and cold drinks? Does the temperature affect the cold drinks? Whether it is purchase of cold drinks, whether it is true or not. So if there is any relationship, it will be positive or negative. Otherwise, when the value of R is 0, it means there is no relationship between the variables. Now, let's take one example where you can see R studied is related to the marks obtained in terms of grade. You can see 70, 80, 90 and 100%, and R studied in terms of 10, 20 and 30 hours. So here you can see that number of hours studied is increasing the grades, increasing the percentage. Number of hours studied 10 hours, the percentage is 72. If it is 20 hours, it is going to 82. And if it is more than 25, 28 or something, then it becomes 92 or 93. So which means that there is a positive relationship between the two variables. And when we compute the correlation coefficient of these two series, of these two data, we get R equals to 0.89. So that is how the values are calculated. Now you will have a question in your mind that how we calculate the value of R. So students, that is also not very tough. again I repeat, statistics is a very simple branch of mathematics where we have a calculator as well to calculate everything. Only thing we remember are the formulas. I'm giving you one more graph to understand. When we get the scatter diagrams, can you see the value of R is 0.4, and though it's a scatter diagram, the dots are scattered but they are going in a direction. And we can say there is positive correlation. Likewise, when the value of R is 0, the scatter diagram is showing dots all over the graph, and you can see there is no relationship between the two variables. And the third one is when it is dropping down, the arrow is going in the downward direction. It is a negative relationship where the value of R is minus 0.4. So again, how we get this value of R? You all know that it's a graph with x and y axis and there are two variables. Quickly come to the example and understand now how to get the value of R. This is our formula R, which is calculated as summation of xy minus summation of x multiplied by summation of y upon under root of n multiplied by summation of x square minus summation of x total square multiplied by same case for y. So this is a formula, first of all, that we have to understand, and finally we have to mug up, because statistics has very long formulas and not many times we have to really mug up the formulas. For after understanding, we have to learn what it is, and once you are into the process of doing and you start making the tables, then you will find that you can write this formula very easily. But for the first time when we are learning, we have to understand what is happening over here. So this is our formula. This is one example, solved example for you all. Find the value of the correlation coefficient age and glucose level. So here the two variables are age and glucose level. You can see over here 1, 2, 3, 4, 5, 6 are 6 people. Age is the age of that person. I am denoting that variable age with x, and glucose level is y. So glucose level is denoted by variable y. So two variables are age and glucose level, and we are trying to find out that what is the glucose level of a person at a particular age, or does the glucose level increases with age or decreases, or whatever is the relationship. We want to find out that is there any relationship between glucose level and age. That is our question. So we have started. First we have calculated x into y. X is what for the first case, that is the first person, age is 43, glucose level is 99. So we found 4257. Similarly, x square is 43 into 43 and y square is 99 into 99. So likewise I have done the same for all the 6 persons. You can see I have calculated, and I am calculating the totals. Total of x, total of y. You can see the summation symbol over here. Total of xy, total of x square, and total of y square. This is how I have created this table. So I think this is quite simple for you all, because you will get this data whenever you are solving. You will get this data and you have to find out the correlation coefficient. So now these are our values. So from our table we have got this: x is 247, y is this, xy, sigma xy is this, and sigma x square is 11,409, and sigma y square is 40,022. I'm taking you back on the table to see once again what we have done. So sigma x square and sigma y square are the things that you should understand. And then we go ahead. N in the sample size in our case is 6. So n is sample size and it is 6. Now let's calculate the correlation coefficient as per the formula. 6 multiplied by sigma xy. You can see this is sigma xy minus sigma x into sigma y upon, and then what we are doing, n multiplied by sigma x square minus sigma y square and square of that, and then likewise 6 multiplied by 40,000, which is sigma y square minus 486 square. So the answer is 0.5298. So this is our answer. Again, come back to the formula and see what we are doing. Come back to the formula, because once we do the calculations, we need to revisit the formula once again and cross check. So once we are through with the formula, we are going back to our solution, and our correlation coefficient is 0.5, which means it is, first of all, it is positive. Positive means there's a positive relationship between the two variables. The two variables are age and glucose level. So there is a positive relationship between the two variables. If the age is increasing, the glucose level will also increase. This is one thing which we came to understand, we could understand. And the second is that the relationship is neither very strong. It is, though it is a positive relationship, but it is not a perfect positive relationship. Had it been 1, it would have been a perfect positive relationship, but 0.5 means that there is a positive relationship, that the increase in age will increase the glucose level in the body. So that is how we interpret the values when we are using correlation coefficients. So your answer is 0.529809. Okay, and now yet another formula. Now this is a formula where we are trying to reduce the size of the numbers. I take you back on the previous example. You see, we have done lot of huge calculations like 43 multiplied by 99, 21 multiplied by 65, and so on. So is there any way where we can reduce these numbers and then do the calculations, so that the calculations become very easy, and very easily we can do without even the help of a calculator? So the answer is yes. We are going for the next formula. The next formula is saying that xi minus x bar. Now I assume that you know what is x bar and y bar. X bar and y bar is the mean, is the average of that series, and we are trying to find out the deviation. So this is your formula, and I am going on the example. Calculate and analyze the correlation coefficient between number of study hours and the number of sleeping hours of different students. Now we are trying to find out number of study hours and number of sleeping hours. So is there any relationship between the two things, that those students who study more are sleeping more, or those who are studying less are sleeping more? You can see over here the person who is studying for 2 hours is sleeping for 10 hours. The person who is studying for 4 hours is sleeping for 9 hours, which means if your study hour is increasing, your sleeping hour is decreasing, which means one variable is increasing and the other one is decreasing. So there is a kind of negative relationship or a negative correlation coefficient between the two variables. This is what I can see from the data. But is it a perfect negative relationship, or is it, to what level it is a negative relationship? What is the value of the coefficient? Again we will calculate. I have used the second formula, and you can again see I have created the table. X is the first variable, which is the number of study hours, and y is the second variable, which is number of sleeping hours. I've done the total, the summation, which is 30 over here, sigma x, and here it is sigma y, which is my total, and here I am finding out the deviation. Now quickly have a look of the table and understand what is happening over here. Okay, so your time is over. Now you all know what is x minus x bar. How come it is minus 4? Because the value of x bar is 6. 30 divided by n is 5. So 30 divided by 5 becomes 6. So we are actually doing over here 2 minus 6, and which becomes minus 4. So likewise minus 2, 0, plus 2 and plus 4. Similarly for the y series, and then we multiply these two columns. The third and the fourth column is multiplied, so we get minus 8. Similarly, we do the square of the third column and the square of the fourth column. So we get these values. And finally, we are finding the summations of everything. So you can see over here that this is coming 0. These third and fourth columns are 0, and the fifth, sixth, and seventh columns is having certain values. You can see over here what are the values. This is minus 20, and here it is 40 and 10. So we have done the necessary calculations, and I am taking you on the next slide. Sorry. Okay. So basically this is your assignment now. On the next slide I have put an assignment for you all, that I have given you these values, and now you have to, with the help of this formula, you have to calculate the value of R. So that is your assignment, and you have to again revisit the formula, see what is happening in the formula, and then try to substitute the values. The values are there in the last row for you all. Try to substitute these values in the formula and come up with the value of R. After that you will come to know that there is a correlation coefficient which will be negative in nature. I am giving you a little bit of hint over here that it is minus 20. So you might get a negative correlation coefficient, and the answer would be a negative relationship between the two variables. But what is the value of R is your assignment, and you have to calculate. Let's come to example 3 and understand one more numerical where we get few variables in terms of numbers, and we have to just substitute the values of the variables and we can calculate the correlation coefficient. Now in this case you can see the summation of the product of deviations of x and y series from their arithmetic means is 122. So this is one value we got. Now how we interpret this line? Quickly come to the last sentence of the slide. Summation of the product of deviation of x and y series. So this is deviation of x and deviation of y and their product, and then its summation is equal to 122. This is one value we got. Apart from that, we know that n is 15, mean is 25, and mean x is 25 and mean y is 18. You can see here also arithmetic mean of x series is 25 and arithmetic mean of y series is 18. So that is how you have to find out what values are given to you. Number of items, both the series are 15, so n becomes 15. And sum of square deviations, we call it square deviations. So sum of square deviation of x series is 136 and y series is 138. So that is how we have got the data. We are not having the data in terms of two series and numbers, but we are given directly the values that need to be substituted in a formula. So in such a case, how will we proceed? So again, this is an assignment for you all where I have given you all the values. Now you have to apply the formula. This is your formula. You have to apply this formula and substitute the values and come with the value of R. So this is again your assignment. Now next we come to Spearman's rank coefficient correlation, where very easily we can find out with a value called as D. So we are actually trying to make the formula easy. So now we have come to Spearman's rank coefficient correlation. You can see over here we write R with a small k as a subscript equal to 1 minus 6 sigma d square upon n cube minus n. Quickly take this example. This is a poetry recitation competition. 5 participants were accorded following marks by 2 judges X and Y. Okay. Calculate coefficient of rank correlation. So now the data is in front of your eyes. There is X series and there is Y series. These are the marks of 2 judges. 90 and 20 given to first student, 20 and 70 to the second participant, third, fourth and fifth. So that is how the data we have. How we will do? We have X, we have ranks given to those values, we have Y, and we have given rank even to those values. Can you see ranks over here? Rank means now first is 90, second is 78, third is 45, fourth is 36 and fifth is 20. Likewise for the Y we have given ranks. First is 70, second is 55, third is 52, then fourth is 46 and the fifth is 20. Now what we are doing? We are finding out the value of D, which is equal to rank 1 minus rank 2. So rank 1 is 1, rank 2 is 5. So it becomes minus 4. Similarly 4, 2, minus 2 and 0. So you will find that finally sigma D is always 0. Now we are trying to find out the square of D, which is 16, 16, 4, 4 and 0. So summation of D square is 40. And now we can see that everything is done. Here the value of n is 5. Quickly take the formula 1 minus 6 sigma d square upon n cube minus n and substitute the values. 1 minus 6 into 40 upon 5 cube minus 5. So we find that it becomes 1 minus 240 upon 120, which is 1 minus 2, which is equals to minus 1. So there is a perfect negative correlation between the two judges. The two judges are that what is the relationship between the two variables? The judges are not talking in the same way. The marks given by one judge is increasing, and on same the marks given by another judge is decreasing. So there is a perfect negative correlation coefficient. I am giving you a minute to see the slide and understand what is happening. Just see that how I have arranged the ranks. I have arranged the ranks for Y, and then I am doing simple calculation. I am subtracting R2 from R1. D square and substitute the values. Now there is some assignment for you all. I am forwarding you two video lectures, one on data freeze in MS Excel and the other one is how to protect and unprotect data in Excel. You all are requested to watch both the lectures because they will help you when you are creating data in your Excel file for research papers and any kind of survey related analysis. And there is a need to freeze the data when the data is huge, and there is definitely a need to protect and unprotect the data whenever there is an intruder coming, or maybe accidental, to avoid accidental deletions. So students, I stopped here and I expect that you will solve the two numericals which I have given to you and come up with the values of R and share with me what were your values, and watch these two videos as an assignment at home and try both the videos. After watching the videos, try both the features on laptop in MS Excel. So this is Dr. Shubhi signing out from YouTube, and I'll be coming back with one more lecture on the measures of dispersion, and we will learn how to understand the spread of data with the help of measures of dispersion in the next lecture. Thank you very much. Have a good day.